Alright guys, this is page 2 of the notes. Let's work a few examples. Now, this first one, it says slope, and it asks what is it also known as. Slope is the m. It's also known as the rate of change. So in this problem, to get the slope, the rise over the run. 1, 2, 3, 4 over 1, 2. So I got a slope right there of 4 over 2, which reduces down to 2. Now, just to check it, these are 2 points on that line as well. Let's check the slope here and see if it changed. 1, 2, 3, 4, 5, and 6. And then 1, 2, 3. So I got 6 over 3, 6 divided by 3 also equals 2. So it doesn't matter which 2 points on the line you pick, you should still get the same slope as long as it's on the same line. Now, our y-intercept, remember in a problem it's going to be the letter B. So in this, we're looking for where it crosses the y-axis. Boom, right here's the y-axis. It crosses at this point. So let's count. It's at negative 1, 2, 3, 4, 5, and 6. So 0, negative 6. For our x-intercept, we're looking where it crosses the x-axis. So on my x-axis, it hits at this point. It's at positive 1, 2, 3. So the x-intercept is 3, 0. And that's it for those key points. Now, let's look at example 2. Instead of on a graph, we have it on a table. Can we find the constant rate of change? Yeah. Your change in y, this goes up 6 over your change in x. This goes up 3. So we get 6 over 3, which reduces down to just 2. Now, let's check it just to make sure. Let's do 2 more points. So this one, it goes up 4. And this one, it increases by 2. So 4 divided by 2, which also gives us 2. So we know the slope there is just 2. Constant rate of change, the slope is 2. Our y-intercept, well, our x value has to be 0, right? So our y-intercept is going to be that first point. 0, negative 6. Our x-intercept, also called the 0, is going to be when y is 0. So that is our 0, or also known as the x-intercept. Remember, it's only going to have a y value, it's only going to have an x value, so this one's going to be 3, 0. Alright, let's move to the bottom examples. Now, on example 3, let's find the constant rate of change, the x-intercept, and the y-intercept. I'm going to go through 2 different methods. Well, we know that this is in slope-intercept form. Y equals mx plus b. Remember, your m is your slope, which is 2. Our b is our y-intercept. So on this one, I have 2 right off the bat. My slope is 2. My intercept is 4. Now, I'm going to write down a method for you to use your graphing calculator. If you don't have a graphing calculator, what you're going to have to do is use this other method to do this by hand. So, by calculator, here's what you're going to do. You're going to go, step 1, solve to y equals. So for example, if this one, like on number 4, was in standard form, you'd have to change it into y equals. Step 2, what you're going to do is type it into the y equals. Step 3, you're going to hit graph. Step 4, you're going to hit second, graph, which should bring up your table. And then remember, on your table, for your y-intercept, the x is 0, and then for the x-intercept, the y will be 0. Now to do this by hand, here's what you're going to have to do. You're going to have to plug in, for your y-intercept, you're going to plug in 0 for x. So y equals 2 times 0 plus 4. Well, 2 times 0 is 0. 0 plus 4 is just 4. So our y-intercept is at 0, 4. That's good because we have that in our problem. For our x-intercept, what we're going to have to do is plug in 0 for my y. So 0 would equal 2x plus 4. And now we have to solve for x. So move our numbers to one side. Negative 4 equals 2x. Divide by our value. And I end up getting, sorry, I ran out of room, that negative 2 is equal to x. So my 0 is going to be at negative 2, 0. This is working it by hand. This way is working it on a calculator. I'm going to stop the video here and then we'll go into example 4.